Hello, good to see you. Our next problem, we're going to be working on talking about an alternating current situation, okay? And I have noticed that I have a typo in this particular problem. My apologies for the typo, okay? And that is, right, that here I have 220, down here this should say 220. I had copy and paste from another problem that was with 120, and I was just changing the numbers to 220. So my apologies for that error. Okay, so here we're given an equation. We're told that the current I in amperes flowing through an alternating current at time t is given by this equation. Okay, determine the period and the amplitude. Okay, well, our period is going to be our traditional period for sine, 2 pi, divided by the coefficient of our variable, and that is 60 pi. So that period, right, that period ends up being 1 over 30. Okay. Now, later on, you'll learn that the frequency is the reciprocal of that, and so that would mean that I'm going to have 30 of these curves every second, right? The period is 1 over 30, okay? This isn't asked here, but in a science class, you'd learn that the frequency is the reciprocal of that, which would be 30 out over 1, and that frequency, 30 over 1, is going to tell me how often I have this occur every second, right? So I'm going to see 30 of these occur every second, okay? Now, we have the period 1/30th, and our amplitude is simply going to be that 220. Okay? Now, that's our first part. Okay. The next portion, rewrite the function in the form where I have sine, right, b t minus h, right, and hence state the phase shift in the direction. So notice that here I have it written in this form, but here I have factored out the coefficient of t. So what's that going to look like? What that's going to look like is this form. Well, we're going to take that coefficient of t and factor it out. All right, so we're going to have 220 sine, parentheses, representing my angle, 60 pi, parentheses, for this t. Now I need to figure out this number. So in essence, we need to figure out what number times 60 pi will give me pi over 6. Well, how can I do that? I can do that as follows. If I turn on my calculator, second quit, what I can do is say, right, well, what is pi over 6, right, that number, divided by 60 pi. And please, please, please use your parentheses so that you're less likely to make a mistake. I go to 60 pi, there's that number. If I hit math, enter, enter, it'll give it to me as a fraction, and I see that that is 1 over 360. Okay? So, what does that mean? That I would have 1 over 360 goes there. Hence, state the phase shift and direction, right? My phase shift, therefore, is 1 over 360 to the right. Okay? If we are assuming a left-right orientation here, okay, we could say in the positive independent variable direction, but really we're just going to be working left-right right now, so we'll say 1 over 360 to the right. And hopefully that makes sense, because 60 divided by 360 is 1/6, and that's going to be where the pi over 6 comes from. Okay. Then the last little piece, we want to graph this function over 2 periods, and remember to start at t equals 0 because of our domain restriction, which says we're only valid when t is greater than or equal to 0. So we get our same general setup for the graph. Okay, we are centered at 0, our center line, no vertical shift, right? Amplitude up, amplitude down. Okay, our period, what did we say our period was? Was 1/30th. So what does that mean for us? This number over here will be 1/30th. This number over there will be 2/30. So we've labeled that part now as well. And the only thing left to do is to say, hey, I have a phase shift to the right of 1 over 360. Not a very big number. So what does that mean? Right? That I have a sine function that normally would start in the middle, but now it's going to be moved over just ever so slightly. Going to go to a maximum, come back to the middle, go to a minimum, right? And then go back to the 0, right? And all of these really, right, moved over just ever so slightly, 1 over 360, and I can come down, plot my points, right? And I would have my 2 periods. And if I'm not sure, I can double check that on my calculator. Right? So when I go to my calculator, if I have these extra equations in there, I can hit second plus 7, 1, 2, if it's this TI family of calculators. And I can come back to my y equals, and I have 220 sine. Right? Now, if I'm worried that this equation may or may not be correct, let me just use what I had initially. 60 pi minus pi over 6. Right? Now, notice what's wrong here. Do I have my variable t? No, I do not. So, I want to make sure, right, that I come back, right, and write the things correctly. So, 60 pi times my variable minus, and maybe I prefer to see these as a fraction. So alpha y equals, to get my fraction, pi over 6, right? And so now it matches more what I see here. 220 sine 60 pi, right? If you're not sure if you're in radians, always double check. There I am in radians, hitting the mode button. Back to y equals, we see everything, we have that. And now what do we notice is our period. Here's our period. So here's going to be something that you want to be careful about. If I were to graph it now, I'd have that. Whew. That's kind of hard to look at, isn't it? If you press the on button, it'll stop drawing that graph. And what do I notice? I need to come back and change my period. If I change even my period to be between -1 and 1, right? And my y min to be -220 to 220, let's set the y scale to be every 20 points, and I were to graph there, I'd still have this weird looking graph, right? And that's because how small is my period? 1/30th. So let's press on again to stop that graph, and let's go back to the window, right? And let's just look from -1 over 30 to +1 over 30, right? So in that space, I should see 2 periods. Now we're drawing our graph. Graph goes up. Graph comes down, and I can see that in fact I do have that little shift. I do have that little shift to the right, and I see that little shift to the right in all of my plotted points, so I can come back and go ahead and finish my graph if I wasn't sure. Right, and there I am. Alright, so I've got the general idea of my graph. Okay, so playing with the window is very, very important. If you have the wrong window, your graph may not look correct. All right, so that's a very nice problem, fairly straightforward to work through. Okay, if you have questions, make sure you ask them for clarification.